Up until now, we've talked about cutting-edge engineering projects, but I'd like to start this episode by talking about philosophy. The worlds of science and the humanities are much closer than you might think, because both move in search of answers to the big themes in every era. There's this phrase by the 5th century BC philosopher Heraclitus that I find particularly fitting with the topics we'll be discussing here. He said, "No man ever steps into the same river twice, because the river is never the same, and he is never the same man." This means everything flows. And the role of science, and engineering in particular, is to foresee these changing currents and to steer progress, finding new ways of making the best of one's skills. These ideas, in some sense, we find in the reporting by Primo Levi back in the 1980s, when he wrote about the time that he spent aboard the Castoro 6, the Saipem ship that laid the Transmed gas pipeline. Primo Levi talked about automation, a great innovation at the time, observing that every technological process builds upon previously acquired knowledge and the teachings of those who came before us. For Saipem, being open to change means using the experience gained from working with fossil fuels in order to guide the transition to alternative energies, like, for example, offshore wind technologies. But it's also about recovering steel from disused platforms to make something new, or about using skills learned for new projects in sustainable mobility, as in high-speed rail systems. As we know, ingenuity is the engine of change, the power that fuels great transformations. I'm Michael Los, and this is Ingenuity, a podcast by Cora Media in collaboration with Saipem. A journey through the projects, technologies, and engineering solutions of a company moving towards the important goal of shaping a sustainable future. If you don't want to miss the next episodes of this series, click the follow button. And be sure to activate the bell notification. And we'd love it if you'd give us 5 stars on Spotify. On this journey, we have encountered many feats that seemed impossible until they are accomplished. And in the history of Saipem, there's one in particular that, in my opinion, describes very well this ability to use acquired skills to push the limits of the possible a little further. I'm talking about the spectacular transformation of the Scarabeo 9 to navigate the Bosphorus. The Bosphorus is a sea strait, a 30-kilometer-long waterway in Turkey that connects the Black Sea to the Sea of Marmara and represents the natural border between Europe and Asia. It's a very important crossroad. Just think that each year, more than 48,000 boats traverse it, passing under Istanbul's 3 bridges, where the maximum height allowed for passage is about 60 meters. That's like a 15-story high skyscraper. Yes, it seems like a lot, but you've probably already guessed where we're going with this, that standard drilling ships are too tall to pass under. So the ships must be transformed. For Saipem, the opportunity arose in 2017 when it obtained a drilling contract in the Russian area of the Black Sea. The vessel chosen for this undertaking was called Scarabeo 9. It's a latest generation semi-submersible unit designed to operate in depths of up to 3,500 meters. What distinguishes it from other vessels is that it doesn't have a traditional drilling system, instead a hydraulic one. The drilling tower is operated by pistons that slide along a guide, and this is precisely the problem. The total height of the Scarabeo 9, including the tower, exceeds 88 meters, much higher than allowed to cross the Bosphorus. The solution, developed by a team of over 20 engineers, is this. Cut the top part of the tower and build a type of elevator to lower the cut-off part and move it to another area on the ship. Once the ship crosses the Bosphorus, the operation is reversed. It sounds easy, but this work requires 2 months. By now, the Scarabeo 9 has crossed the Bosphorus several times, but watching it pass under the bridges of Istanbul, brushing the undersides with a gap of barely 5 meters, always gives you the shivers. To date, ships of this kind that have entered the Black Sea can be counted on one hand. Among these, there's a very particular one, the Saipem 7000. We've already met this vessel in a previous episode. It was the ship that laid the Blue Stream gas pipeline in the 2000s. And no offense to the captains and technicians working on other vessels, but the Saipem 7000 is truly a special ship. It's the symbol of a changing world. It was designed and built to support projects in the oil and gas world, but for several years now, Saipem 7000 has been the champion of a major new enterprise, offshore wind power. Saipem's debut in this sector was in 2017 with the installation of the world's first floating wind farm, Hywind, off the coast of Scotland. A project completed thanks to the capabilities of the Saipem 7000, which was able to perform extraordinary operations such as lifting and installing turbines onto their foundations. It was an ambitious challenge, and consequently has had a positive global impact on wind power. It has paved the way for the production of this new energy, even in inaccessible areas, far from coastlines. I said that wind power is a new form of energy, but in reality, wind engineering is a very ancient science. So let's disembark the Saipem 7000 for a moment. We'll come back later and climb onto another vessel, a very light one this time, made of papyrus. Our captain is Flavia Frisone, professor of Greek history at the University of Salento. She told me that the kinetic energy of wind altered the history of the world.
The attempt to harness the natural elements to improve the quality of life and make work easier has been a part of human history since time immemorial. But the most important application that comes to mind when we think of the use of the wind energy in the ancient world is a hidden revolution that we can hardly grasp in its full extent, that of sailing. The ability to harness the kinetic energy of the wind to move was probably one of mankind's great technological revolution. The possibility of sailing fast and far with the power of the wind paved the way for the dense network that, through contacts and exchange with the mobility of people and products, but also of ideas, knowledge, customs and habits, shaped the civilization of the ancient Mediterranean. Over time, it would mean creating a system of orientation based on the direction of the wind, which would evolve into the wind rose, a fundamental tool for charting a course centuries before the invention of the compass. In short, it meant the creation of a highly developed system of technical and practical skills and technological innovation which were considered very important in antiquity.
Okay, you've just heard how wind has provided civilizations the push to develop new technical knowledge to improve and progress. But there's a but. From antiquity comes a story, or rather a myth that warns us. A sort of warning for us who, after more than 2,000 years, are still interested in the forces of nature. The protagonist is Ulysses, or Odysseus, as he's called in the Greek world. And during his adventures, he stops and stays for some time with Aeolus, the guardian of the winds. When it's time to leave, Aeolus gives him a light breath of the western wind Zephyr and imprisons all of the other winds, the ones that would have blown him off course, in a wineskin, which he gives to him, and Odysseus is then ready to set off on his travels.
He is overcome by fatigue and falls asleep. Then his companions, driven by curiosity, but above all by greed, thinking that it contains treasures that Odysseus wants to keep for himself, they open the wineskin and release all the winds that were trapped inside. A furious whirlwind is unlashed, driving the ship back to the floating island of Aeolus. On seeing the hero again, he reproaches him for having wasted the precious help he had received that should have been responsibly guarded and wisely managed. For Homer, the extraordinary and fearsome power of the wind can be controlled and harnessed for the benefit of man. But man must have respect for it. And I believe that the myth, as always, hides a deeper reflection that can also speak to us today. We too, faced with the challenge of exploiting nature's precious gifts, have the duty not to forget the responsibility and care that this requires.
Care and responsibility. These words are very important to Saipem people, especially while harnessing an ancient force like the wind, especially in today's energy sector. As we said at the beginning, progress requires the wealth of past knowledge, and it's precisely Saipem's experience with offshore infrastructures that allows them to be at the forefront in the development of offshore wind power. The most emblematic project in the field of fixed installations is NNG, an offshore wind farm recently built off the coast of Scotland. With its 54 turbines, it can generate up to 450 megawatts of power. We're talking about enough energy to power 375,000 homes. The plant covers a surface area of more than 100 square kilometers and is located about 15 kilometers from the coast at depths ranging from 40 to 60 meters. Saipem was responsible not only for the design, but also for the construction and installation of the foundations. The seabed here is particularly difficult, and drilling 3-meter diameter holes in the rock is not a simple operation. But that's when Saipem 7000 comes to the rescue. As promised, we're getting back on board this spectacular vessel to learn more, and we'll start with its name. It's called Saipem 7000 because it's equipped with 2 enormous cranes that can lift over 7,000 tons each. To give you an idea, that's like taking not 1, but 2 Eiffel Towers out to sea. To understand more about this, I asked Master Francesco di Pietro to take me on a sort of virtual journey on the Saipem 7000. He knows the ship very well. He climbed aboard for the first time in the late 1990s as a cadet, and then took command in 2011. He told me about its sophisticated dynamic positioning system, which, during operations, allows it to remain perfectly in place. But that's not the only thing that makes it so special.
But we have to also talk about how the thruster running. This is thanks to 12 generators, around 5,600 kilowatts each. So in total, we have the capability to provide for the vessel 70 megawatts. 70 megawatts is like a city with the full of lights. Saipem 7000 is the third crane vessel biggest in the world. And for this reason, many clients require Saipem 7000 to do the activity because she is a very performant vessel. But without a qualified personnel, the asset cannot operate in high standard. So we have to say thank you to all the people that are working for this vessel, that put their effort and their professionalism, every day, every single minute on that vessel.
It's true. Without people, without their passion and competence, a vessel is just a vessel. And hundreds of people work on Saipem 7000, with teams alternating on 24-hour shifts. Highly skilled men and women, along with their ingenuity, make this wonderful floating factory work, which, as Master Di Pietro says, never ceases to amaze.
Saipem 7000 is a strategic asset for Saipem, and when you will join that vessel, you to be proud of this kind of opportunity, because means that Saipem believe in you. Is usually what I say to the young people is to have the passion and the curiosity to learn. Because in the offshore unit, and especially on this vessel, you can never say you have done it all. But I can say also that despite the fact that I have the role of captain, I still learn day by day. Because Saipem 7000 is not really like a book that you read, you learn, but you have to leave the vessel before you can say, okay, I know this vessel.
While the journey of Master Di Pietro and his crew moves onward, Saipem continues to look ahead, because technology is never at a standstill. It's constantly evolving. Like, as in the latest frontier of offshore wind power, floating installations. One further step towards a zero-emissions future. For some time now, technicians and engineers have been working on new solutions to avoid having to fix wind farms to the seabed, especially in very deep water. The winning idea, also the result of ingenuity, was to create floating structures. It was an intuition that is now transforming the way we look at offshore wind power. And for Saipem, the result is the proprietary technology called StarOne. It's a semi-submersible floating foundation. And to describe it simply, imagine a thin, three-pointed star structure laying just below the water's surface, with floats at each of its 3 points, and right in the center, the wind turbine tower. This provides a stable structure, even in adverse weather conditions, and does not need to be fixed to the seabed with rigid poles or beams. There are simply anchors, which leave it free to float with the waves and currents. StarOne was designed to be modular and scalable, making manufacturing simpler, and can be adapted to wind turbines of different power potentials without having to redesign it every time. If the Saipem 7000 is the symbol of the path towards energy transition, StarOne already represents the next step, because floating installations allow the capture of wind power even in areas that would otherwise be inaccessible with previous technologies. As we continue to talk about transformations and new ingenious inventions, perhaps you're wondering, what happens to all the previous built stuff? To all the no longer needed, out-of-use structures and platforms? Lavoisier, a brilliant French chemist and physicist of the 18th century, said, "Nothing is created, nothing is destroyed, everything is transformed." Or, to use today's language, we're creating a circular economy. At Saipem, one of the most surprising examples concerns the dismantling or decommissioning of the Miller platform. This was a structure installed in the British section of the North Sea, serving a gas and oil field. And once the resources were exhausted, in 2007, the decommissioning of the platform was necessary. This was not an easy challenge. We're talking about an enormous structure and also very heavy. And this is where the flagship, specializing in lifting really large loads, comes into play. Yes, I'm talking about the Saipem 7000. Once dismantled, the platform's modules were hooked up to the ship's powerful cranes and brought ashore. 97% of the material was recycled and repurposed for other needs. Thousands of tons of sheet metal, iron, and steel transformed into underwater pipes, foundations for wind turbines, and even into tracks for new railway lines. So we started by crossing the Bosphorus aboard the Scarabeo 9. Then we climbed onto the sailboats of ancient civilizations, and finally onto the cutting-edge vehicle, the Saipem 7000. Now let's return to dry land, to travel at almost 300 kilometers an hour on high-speed rail lines. Because true evolution looks at tomorrow's world holistically, not just towards clean energy, but also to sustainable mobility. The transport sector is central in fighting climate change and central to the path of decarbonization. We cannot work towards generating clean energy from wind power and then continue to push road transport for goods or congest those roads with private vehicles. Not only does creating cutting-edge rail transport systems reduce environmental impact, but also connects territories, promotes economic growth, and improves our quality of life. Think of those who need to travel for distances to work. With a good rail system, they can do so more efficiently and perhaps even get home earlier. Students forego relocating to another town just to attend classes. The future travels by rail, and Saipem has been, and still is, involved in major railway projects around the world. From the first railway in the United Arab Emirates, which crosses the Abu Dhabi Desert, to the Italian high-speed lines, such as the Milan-Verona, the Florence Bypass, and one of the more complex lines, the Milan-Bologna. This is a high-speed, high-capacity railway line built in the early 2000s, connecting these two important cities, a distance of 250 kilometers. A huge challenge which employed more than 5,000 professionals, technicians, and workers. I spoke with some of them to understand how a sustainable infrastructure is built, and they told me that every kilometer is a different adventure. Because along the way, you can encounter all kinds of interference, from motorway junctions to rivers, from underground networks to land reclamation areas. In this project alone, Saipem engineers solved more than 4,000 interference issues. And there's a story in each one of these. I'll tell you about a few. In order to cross the Po River, a cable-stayed bridge was built, which at the time was the longest railway bridge in Europe. Then, in Reggio Emilia, the construction of a high-speed rail line was interfering with an older motorway overpass. This overpass was removed and replaced by a system of bridges designed by the famous architect Santiago Calatrava. They are spectacular structures and have played an important role in the urban development of the area. Working in Italian territory also means discovering many archaeological sites. For example, during the construction of another high-speed line, the Milan-Verona, Saipem technicians brought to light dozens of archaeological finds. And you're now wondering what happens when, during excavations, you come across a necropolis from the 12th century BC or the remains of a settlement from the Roman era. Well, as our history represents a precious heritage, the past is rightly preserved. And today, if you happen to pass by the town of Bergamo in Italy, Nearby, at the Archaeological Museum of Great Works, you'll be able to admire some of the historic pieces discovered during those projects. Construction sites for sustainable infrastructures must be, by definition, not only sustainable, but also have minimal impact on the community. For example, during the construction of the Milan-Verona line, an innovative technique called landfill mining was used, which allowed to differentiate recovered materials from a closed landfill and then repurpose them into other production cycles. Tunnel excavation is another area for innovation. In this case, a specific boring machine was built, and to facilitate the cutting procedure, Saipem technicians used a biodegradable and eco-compatible foam. Once the excavation was completed, the foam disappeared as it made contact with the atmospheric agents, leaving the uncontaminated excavated material ready to be used, fully respecting the environment. And do you know what's really cool? That while I've been telling you about these innovations, somewhere in the world, there's someone who's already thinking about the next big idea, developing even more advanced, sustainable solutions. Progress is made one step at a time, but at a constant pace. Whether it's a factory that sails the seas, a floating wind turbine that spins, or a train that travels at 300 kilometers per hour. Ingenuity is a podcast by Cora Media, produced in collaboration with Saipem. Written by Alessandra Menozzi. Translated and narrated by me, Michael Los. Editorial curation by Graziano Nani. Sound and music supervision by Luca Micheli. Post-production and editing by Aurora Ricci. The project manager is Anna Nenna. The producer is Alex Peverengo. The post-production coordinator is Matteo Scelsa. The studio sound engineers are Luca Possi and Lucrezia Marcelli.